dividing polynomial is very similar to dividing numbers. For instance, if I divide the number, let's do 44 divide by 7. If I divide 44 by 7, and I'll write it as a fraction form like so, then the result will be, let's see, 42 by 7 is 6, and we have a remainder of 2. So we have 2 over 7. Okay? So let's use a little bit of vocabulary here. This number, 44, is the dividend. This number, 7, is the divisor. The result will be the quotient. And here we have, so 6 is the quotient, 2 is the remainder. And 7 is the divisor one more time. Okay? Another way to write it, so this is another way to write the above. Is I can write 44, okay, equal the divisor 7 times 6 plus the remainder 2. This is something called a division algorithm. So again, this is the dividend. This will be the divisor. This will be the quotient. And this will be the remainder. This format is called division algorithm. How does this apply to polynomials? Okay, if we let P of x, D of x, Q of x, and R of x be polynomial functions, then on the next page, if you want to divide, let's say P by D, okay, then P of x divided by D of x, so the dividend divided by divisor will be the quotient Q of x plus the remainder R of x. Okay? R of x over D of x, right. I've been thinking about the algorithm. And then, or using the division algorithm, and this is actually the Euclidean algorithm. Euclid in, let's say, about 3rd century AD, developed this algorithm and said that P of x will be really D of x, the divisor, times the quotient plus the remainder. Like so. So, if we need to divide a polynomial, one polynomial by another polynomial, then it's the same as having the polynomial, the dividend, multiply equals to the product between the divisor and the quotient plus another one that is a remainder. Okay, this division algorithm is actually, or Euclidean algorithm, is used in a number theory in different ways. It's actually more important than you think. All right, let's see how this works in reality. And the first example, we're going to divide the following. So we want to divide the polynomial 6x squared minus 12x I'm sorry, 6x squared minus 26x plus 12 by x minus 4. Okay. So what we'll do first, we'll do division, we'll perform long division. I want to show you long division as well as synthetic division. So what is long division? Long division is basically what we do when we divide numbers, except now we work with polynomials. Okay, so the dividend, we'll write the dividend first, 6x squared minus 26x plus 12, and we want to divide it by x minus 4. So the quotient will be written on top. Okay, like so. So in order to get to 6x squared, I need to multiply x by 6x. Since I have in the quotient I have 6x, notice the position. I'm positioning above the x in the dividend. The same way as we do with the decimal placement, with the place value, as we divide numbers. So I won't position it above the 6x squared, but I position above the identical term or the like term. So now if I multiply the quotient by the divisor, I get 6x times x, or 6x squared, and then 6x times negative 4, which is negative 24x. And the next thing I'll subtract, the way we do with numbers. So 6x squared minus 6x squared, that goes to 0. Here I have positive 24x, so negative 26x plus 24x gives me negative 2x. And now I'll drop the 12. So to multiply something by x to get negative 2x, I need to multiply by negative 2. So negative 2 times x is negative 2x, and negative 2 times negative 4 is positive 8. Subtract. So the negative 2x become positive 2x, so 0 for the first position. And here we have 12 minus 8, and the result is 4. And I have nothing to drop, so this is the remainder. So this will be r of x, the remainder. And this is the quotient, so this is q of x. So the result can be written in two forms. One, we're going to say that 6x squared minus 26x plus 12 over x minus 4 is 6x minus 2 plus 4 divided by x minus 4. Okay? And using the division algorithm, I can say that 6x squared minus 26x plus 12 can be factored as what? The divisor, x minus 4, times the dividend, 6x minus 2. But however, we do have, so it's not a true factoring. It's a product of two factors, but we do have this remainder of 4. Now, why it is useful to write it in this form? Think about it. Think in terms of long-term behavior. When x is a large number, when x goes to infinity or negative infinity, what happened to the remainder here? What is 4 divided by x minus 4 when we take it to the limit? So I'm kind of borderline with calculus now. It's what happened when x is getting very large. It is closer and closer to 0. So if x is large enough, this little tail disappears. And we have a very comfortable polynomial to work with, 6x minus 2. This is actually what we call an oblique asymptote. It's a line, when x is a large number, then this tail, this remainder, divided by the divisor, approaches 0 in a hurry. Think about x equal 1,000. What is 4 divided by 1,000 minus 4? 4 divided by 996. It's a very small number. We can throw it away, so to speak. Okay? And we end up having a line 6x minus 2. And what is 6x minus 2? It's a slanted line. It's oblique line. That's why we call it oblique asymptote. All right? So, except for this remainder, we can write the polynomial sort of product of two factors. Of course, it won't be algebraically correct, but it can be some sort of approximation. Okay, so you have these two results. Either you write it like so, and if the assignment asks you to come up with the division algorithm, then this will be the other solution.